In this video, we're going to talk about factoring trinomials, and we're only going to be talking about this when our leading coefficient is 1. So all the trinomials that we're going to be factored are going to be in the standard form of a trinomial, and that standard form is ax squared plus bx plus c. So we're looking at factoring things where there is no leading coefficient because the leading coefficient is just 1. So we're basically going to be factoring things that start with x squared plus or minus some number times x plus or minus a number at the end. We need to make sure that we are really proficient at this because next week we're going to get into factoring even more complicated trinomials where there is a number out in front here. So we want to feel very confident in our ability to factor when the leading coefficient is 1 or there is no coefficient there before we move into the harder stuff. Factoring is one of the hardest things that we're going to cover in algebra, and factoring is one of the things that is going to be the most used as you move forward in math. So it is one of those times where we can't just ignore it because we're like, oh, that's hard, I don't want to do that. You are going to see this every single year. You're going to see it in geometry, you're going to see it in Algebra 2, you're going to see it in every algebra or every math class that you take beyond this. So the more we can just dig in and really understand this now, the more it's going to benefit you in the future. So when we are factoring trinomials like this, what we're basically trying to do is determine which two binomials did we multiply together to get this trinomial. So last week, we were multiplying the two binomials together. Most of the time, we see that those middle two terms combined, and we ended up with an answer that was a trinomial. This week, or looked like these examples down here. This week, we're starting with what was last week's answer, and we are working backwards to figure out what did I multiply together to get that. So when we do this, when we factor these, we need to, number one, make sure that it is written in standard form. For this week, as you move through some of the problems, not in the original, but as they start to progress in some of the harder problems, even on the mild, or not, maybe not the mild, the medium, actually, maybe both, you are going to sometimes find that there is a number in front of the x squared. The reason why you're going to see that there is because there's also a greatest common factor. So I didn't put an example of that in the notes, and I probably really should have. So I want to make sure we talk about this week, if you see any sort of leading number in front of the x squared, it's because you need to factor out a greatest common factor first. Then you would factor the trinomial that's left. So now let's talk about how we factor these trinomials. So we need to think of, or even write out, all of the factors of that last term, of this c term here. So what are all the numbers that I could multiply together to give me 6? One thing to consider when you're doing that is if this last term is positive, that means the two numbers that you multiplied together had to have the same sign. Whether they were both negative or both positive, we multiplied them and got a positive. So either both positive or both negative. If this last term is negative, like you'll see on the back side of this page, that means that the factors have opposite signs. So one was positive and one was negative. This is going to be important because we have to consider what those signs are, because the pair of factors that we're going to choose are the ones that add together to give us the number in front of the x here. So that give us the b value, the number in front of the x. So determine which pair of factors add to give the coefficient of the middle term. Once you've figured out what those two numbers are, you can go ahead and you can write out your binomial factors where you're going to have your variable plus or minus, whatever your first factor was, times x plus or minus, whichever sign it needs to be, your other factor, like that. So our answers are going to be to these two binomials like that. So let's look at this first example. X squared plus 5x plus 6. So it's in standard form, that's the first thing to check. And then I need to think of all of the factors of the last term. And my last term is positive, and they add together to give me a positive. So that means that these must both be positive numbers. So my factors for 6 are somewhat limited. All I've got to work with is either 1 and 6 or 2 and 3. These are the only combinations that multiply together to give me 6. And I want to pick the combination that adds together to give me the coefficient on the x, or the b value. So it's got to be 2 and 3. So now I know what my factors are. It's x plus 2 and x plus 3. If I double distributed this back out, I would end up with this same expression right here. One thing to note when you are looking at answer keys and things like that, the order of these two binomials doesn't matter. So I could write this as x plus 2 times x plus 3. I could also write this as x plus 3 times x plus 2. The order that you put the binomials doesn't matter because order doesn't matter in multiplication. That's our commutative property. This next one looks very similar. The only difference is, well, I switched to a's, but now instead of plus 5a, it's minus 5a. I still have a positive c value, a positive number being added on the end here, which means my two factors have to have the same sign, but because they're adding together to give me a negative number, it means that I must be thinking of two negative factors. So it's either -1 and -6, because those multiply together to give me positive 6, or it's -2 and -3. Well, the only ones that add together to give me -5 are -2 and 3. So those are my factors, and so it's a minus 2 times a minus 3. I could write it as a minus 3 times a minus 2. That order doesn't matter, it's correct either way. There's no standard way to write out the order of the factors. I'm going to keep going. This is in standard form, so I'm thinking of factors of 10 that add to 7. 10 is positive, so they have the same sign. They have the same sign and they add to a positive, so I'm considering all the positive factors. So factors of 10 are 1 and 10 and 2 and 5. 2 and 5 is the combination of factors that add together to give me 7. So my factors are x plus 2 and x plus 5. Again, you could have these switched. It could be x plus 5 times x plus 2. In our fourth example, we are looking for factors of positive 16, so they have the same sign, that add to -10. So they're both going to be negative. So all the possible combinations for 16 are -1 and -16, -2 and -8, -4 and -4. So now I'm starting to have some more possibilities because I've got a larger number and it has more factors. Well, -2 and -8 is the combination that adds to -10. So my factored form here is y minus 2 times y minus 8. As the numbers get larger and you have to start to think of more combinations, I would think about, you want to list your factors in some sort of logical way to make sure that you're covering all your possibilities as you're thinking through this part of it. So I usually will start with, I always know it's 1 times the number, and then I'll go to 2. Well, is 2 a factor? Yeah, 2 times 8. And then, is 3 a factor? No, 3 is not a factor of 16, so I don't need to list it. Is 4 a factor? Yes, 4 is a factor. Well, 4 times 4 gives me 16. Because these are the same number, I know that I'm done. There are no larger factor combinations that I need to consider before I just start making repeats of the ones that I already have. All right, we have more examples on the back, because this is a pretty complicated topic and I want to make sure I give you a lot of different situations that you might encounter. So our next example, it's in standard form, and I'm looking for factors of -18. So this is the first time that we're seeing one where this last term here is negative. And because this is negative, I'm going to have to consider the possibilities of positive, one term's positive, one term's negative, but it is going to matter which one is which. So factors of 18 are 1 and 18, 2 and 9, 3 and 6, 4 is not a factor, 5 is not a factor, 6 is already on this list, so I know that I have them all. I also know that when I add them together, I get a positive number. So that means that my positive numbers are going to be my larger numbers. So -1 times 18 gives me -18. -2 times 9 gives me -18. And -3 times 6 gives me 18. But only -2 and 9 add together to give me +7. So that's my combination. And it's x minus 2 times x plus 9. Again, you could write x plus 9 times x minus 2. Either way, the answer is correct. So another example with a negative. So -24. I have to think of factors with opposite signs. So I have 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 is not a factor, 6 is already listed, so I know I have all my factors. This time when I add my factors together, I'm looking for a negative number, so I need the larger numbers to be, whoops, that was messy, that's a -24. I need the larger numbers to be negative. And so when I look at how these combine together, 3 plus -8 is what adds together to give me -5, so that's my pair. This is m plus 3 times m minus 8, or you could write it as m minus 8 times m plus 3. Sometimes it's a little trickier, like these two problems where our last term is negative, because we just have a little bit more to consider in terms of which number's negative, which number's positive. Creating this sort of list of factors can be very helpful in helping you determine that. This week, as you're working through your work, I want to see this listed. As we start to get more proficient with this, you don't have to continue doing this, but I think this is a good place to start for this week. We have another trinomial. It's in standard form. It is, the last term is positive, so I know they have the same sign. So my factors are 1 and 12, 2 and 6, 3 and 4. 4 would be the next number. It's already on the list, so these are all my possibilities. I'm looking for the combination that add to a positive, so they all need to be positive. And 3 and 4 is my factor set that I want to choose, or my solutions here. Or not solutions, but my factors that I want. So in the factored form, it's x plus 3 times x plus 4. And again, you can check these by multiplying them back out. If I were to double distribute any of these, I would end up right back where I began. So it's very easy to check your work on these. These last three examples are a little bit more special, and they even have a special name. So what makes them special is when I look at them, I don't see a trinomial. I see a binomial. But my first term is squared. So it's n squared minus a number on all of these. And it has to be subtraction for this to be the case. We call this a difference of squares. And I'm going to explain that in just a second. So we call it a difference of squares because in this case we're using the word difference because difference means subtraction. Notice all of these are subtraction. So it's subtraction of two things that happen to be perfect squares. N squared is a perfect square. 100 is a perfect square. X squared is a perfect square. 25 is a perfect square. Y squared is a perfect square. And 36 is a perfect square. So these are a special situation, and that's what we call them. One way that can help you understand how we're going to factor these is this is the same thing as if I had n squared plus 0n minus 100. 0 times anything is 0, it's gone, so I don't have to write that middle term, but technically this is what's going on here. So I'm still going to end up with a binomial times a binomial. But because the final number in each of these is a perfect square, these two, the two terms that are in each binomial are just the square root of the first term and the square root of the second term. So the square root of n squared is n. The square root of 100 is 10. 1 is a positive, 1 is a negative. If I want to tie this back into the same process that I solved all the first examples, I'm thinking of factors of negative 100 that multiply together to give me a negative 100. So they have to have opposite signs. Notice I have opposite. But they add together to give me 0. So I could list out all of them. Three is not a factor. 4 is a factor. This is going to take a while. 100 has a lot. 6 isn't, 7 isn't, 8 isn't, 9 isn't, 10 is. And this right here is the set of factors that add together to give me 0. If you can get to a point where you recognize when it's a difference of squares, because, oh, hey, the first term squared, there is no middle term. There is no term with n to the first power, and my last number is a perfect square, and it is subtracted. You don't have to do all of this factor listing. It's a little bit quicker to kind of jump to there. So I've already kind of told you that these last two are also difference of squares. So I know the square root of x is x. One's going to be positive, one's going to be negative, and the square root of 25 is 5. Because my factors of negative 25 that add together to give me that coefficient of 0, I'm going to find are positive 5 and negative 5. And actually 25 doesn't have a lot of factors. You can see it right there. So whether you choose to keep going with this same method or you start to look for that pattern to realize that I don't have to spend all that time working, you're going to arrive in this same point here. So for our last one, y squared minus 36, both of these are perfect squares. Square root of y is y. Square root of 36 is 6. 1 is positive, 1 is negative. And the same thing holds for these difference of squares. It doesn't matter if you do the n minus 10 first, followed by the n plus 10, or the y minus 6 first, followed by the y plus 6. The order of the two binomials doesn't matter. It's just that you need to have them both there. So that is our second set of notes for the week. You are now ready to practice anything from the bottom row of the choice board. You need to make sure you have practiced at least one assignment from the bottom row. Again, factoring is not easy. We need a lot of practice with this, and we need to feel very proficient in our factoring of trinomials, or in this case, technically a binomial, where the leading coefficient is 1 before we move on to what we're going to be learning next week.